In this video, we are going to look at how the source code that runs on the Arduino computer drives the focus stacking system. I'm going to explain the code in some detail because I anticipate that some people who are keen on gametophyte fern photography and who want to copy the system may not know quite so much about electronics and Arduino programming. This video is for those people. If you know more than I have assumed, then please skip ahead. If you would like a more condensed version, please try the video Running the Focus Stacking System Source Code Summary Version. If you would like to see how the wiring of this system is set up, please look at the video Automation of the Focus Stacking System. In this video, we will talk through the source code in detail and then look at how to use the Arduino IDE to drive the camera and the focus block. To download a copy of the source code, please visit the URL shown on the screen. In the first section of the video, we are going to look at the simple commands that a user has to give to the program in order to make the focus stacking system behave in the correct way to fit their photographic subject. In the second section, we will talk through the structure of the program in detail so that users can understand why these commands work in the way that they do. The sections of the program that need to be modified to alter the behavior of the system are the variables at the top and the numbers in the delay command of the trigger function at the bottom of the program. The variable shots controls the number of photographs that will be taken, while the number in the delay command of the trigger function controls the delay between shots. This delay is important in those situations where settling time will be useful between the movement of the focus block and the taking of the photographs. The last parameter that we will need to change sets the distance variable. The number before the multiplication sign refers to the number of microns moved by the focus block between shots. This is very important for making sure that the focused areas between adjacent slices overlap. If you would like to know more about this, please watch the video Measuring the Depth of Field in the Focus Stacking System. We can now start to play around with the system to change the length of the focus block movement and the delay between the focus block moving and the camera firing. Here's what happens if we have a 300 micron movement of the focus block and a 1000 microsecond delay. The next option shows what happens with a 300 micron movement and a 3000 micron delay. The last video shows what happens with a 10 micron movement and a 500 microsecond delay. Using this program, it's not possible to have the focus block moving continuously while the camera is firing. We would have to rewrite the program in order to do that. Now that we have seen how the alteration of these variables affects the behavior of the focus stacking system, we will look through the program in detail to see how it works. The source code that we run has a main method, 3 functions, and a number of variables. The functions are called setup, trigger, and step. Setup is a standard function in Arduino programs, and trigger and step are called from inside the for loops in the main method. There are a number of variables that are initiated at the top of the program, and we will look at those first. The shots variable allows us to set the number of photographs that the camera will take before the program exits. The micron variable is next, and it is a little bit more complex to understand. The stepper motor's smallest step drives the focus block forward by 1/128th of a micron. In order to move the focus block by 1 micron, we have to move the stepper motor forward by 128 steps. This movement of 128 steps, or 1 micron, is referred to in our code by the variable micron. The next variable is called distance. This is the distance that the focus block will move in between camera shots. Usually we would like the movement to be somewhere between 1 micron and about 300 microns. And in this line we can set that number in the brackets before the multiplication sign. The number of microns that we have specified is then multiplied by the figure 128 that is represented by the variable micron, so that the stepper motor will move by the correct number of rotations. In the next section of code, we set the Arduino pins that we will need. The 2 pin is set to STP, the 3 pin is set to DIR, and the 13 pin is set to fire. STP and DIR are used to drive the stepper motor via the Big Easy driver board, which is discussed in more detail in the video Automation of the Focus Stacking Setup. The STP terminal on the Big Easy driver board is a logic input. Any transition on the STP pin from low to high triggers the motor to step forward by 1 step. The direction of the step is controlled in this setup by the DIR pin. The DIR pin is also a logic input. The pin determines the direction of the motor rotation. Changes in state only take effect when the STP pin changes state. The fire pin is used to drive the camera shutter. Next, we move on to the setup function. In this function, we set the STP, DIR, and fire pins to output, so that they will be ready to send signals down the wires rather than to receive signals from the wires. We also initially set the STP pin to low and the DIR pin to high. We then open the serial connection for debugging, and this is set to 9600, which is important to know when we come to set up the Arduino IDE interface later. Before we look at the main method, we will look at the details of the trigger and step functions, which are called from the main method. The trigger function triggers the camera via the infrared remote control. When trigger is called, first there is a delay that is currently set to 1000 milliseconds. This is to allow any vibration in the system to settle after the movement of the focus block. The settling time can be increased or decreased by changing the figure 1000 that is set in the delay functions. The digital write commands switch the fire pin to high to trigger the camera shutter, and then to low again so that it is ready to fire again next time. There is a delay function before and after the shutter firing so that the settling time can be introduced at both of these points. This is the whole of the trigger function. The summary of what's going on here is that the trigger function fires the camera shutter. The figure 1000 can be increased or reduced to change the settling time before and after the shutter is fired. So it is quite a simple function. Next, we look at the step function. Once again, here we use the digital write function to switch a pin to high and then low. This time it is the STP pin, which causes the stepper motor to move in the direction specified previously by the DIR pin. Once again, we also use a delay function to stagger these changes to the pin state. The bottom line here is that the step function is the one that makes the focus block move. At this point, we are not saying anything about when or how far. Lastly, we return to the main method and see how it all works together. When we call the main method, first we initialize some variables. These are the integers I and j, and the character variable input. We then print the sentence, press enter to start, to the serial terminal, which we will see later in the video. This sentence asks the user to start the program by putting the mouse pointer in a box and pressing the enter key. Once we have done this, the main method moves on by calling a for loop. Using the I variable, the camera calls the trigger function that will fire the camera shutter and increments I. It keeps doing this over and over again until I reaches the number that we have previously set in the shots variable at the top of the program. There is another for loop inside this first for loop, and just after the trigger function is called. This means that after the camera shutter fires, the second for loop is called. The second for loop increments the j variable and calls the step function. The step function moves the stepper motor forward by one of its tiniest steps. And the for loop makes sure that it keeps doing this until it is moved forward by the number of steps that we specified at the top of the program in the distance variable. When the stepper motor has moved forward by the right number of steps, the second for loop exits and we go back round to the trigger function. This combination of for loops effectively means that the whole system will alternate between firing the camera shutter and moving the focus block. And the second for loop makes sure that the movement of the focus block is the length that we specified. So in summary, when the user presses enter to keep the main method going, we enter a couple of nested for loops that will alternately move the focus block forward and fire the camera shutter. They will keep doing this until the number of camera shots specified in shots is reached. At that point, the program exits. Having seen how the program works in detail, it may make sense for you to go back and look at the first section of the video again to see once more how the important variables affect the system. At this point in the video, we are now going on to show how to set up the Arduino IDE so that users who are making a copy of the system can learn how to run the software for themselves. The first thing that we need to do is to install the Arduino IDE on the computer that is driving the Arduino, and I will assume that you have done that. Here is the user interface with our code already loaded and saved. Next, we check the menus to see that the Arduino has been detected. We select it if it hasn't. Then we open the serial monitor. This is the serial monitor, open and ready to go. The drop-down menu at the bottom should be set to 9600 as we specified in the code. The serial monitor is displaying the command press enter to start. This means that we have to click in the white bar at the top with the mouse and press enter in order to start the focus stacking system. Before we press enter, it's a good idea to check that the camera is in the right mode to be triggered by an infrared remote control. When we press enter, the first thing that happens is that the camera shutter will fire, and then the focus block will move. We can now start to play around with the system to change the length of the focus block movement and the delay between the focus block moving and the camera firing. Now that we have talked through the code in detail, it should be possible for people copying the system to run the code with the correct parameters for their own photographic requirements. If you would like more information, please visit www.chlorophilosophy.uk.